Welcome to the world of Python data types. In this video, you'll learn about the fundamental data types that Python offers. Understanding these types is crucial for writing effective and efficient Python code. We'll explore the built-in data types in Python. Let's start with numeric types. Python has two main numeric types: integers, represented as int, which are whole numbers without decimal points, and floating point numbers, represented as float, which are numbers with decimal points or in scientific notation. In Python 3, integers have unlimited precision, meaning they can be as large as your memory allows. Some of the features of integers are no maximum size, limited only by memory, support for binary, octal and hexadecimal representations, and automatic type conversion in operations. Floating point numbers, on the other hand, follow the IEEE 754 double precision format, which is a 64-bit format. Here are some examples of how to work with numeric types. A is assigned the integer value 42. B is assigned the integer value -10. Big underscore number is assigned a very large integer. You can also represent numbers in binary by prefixing them with 0b, in octal by prefixing with 0o, and in hexadecimal by prefixing with 0x. Here are some examples of floating point numbers. X is assigned the value 3.14, Y is assigned the value -0.001, and Z is assigned the value 2.5e6, which is 2,500,000.0. Now let's explore complex numbers in the Boolean type. Complex numbers are numbers with real and imaginary parts, written in the form a plus bj, where j is the imaginary unit. These are commonly used in engineering, physics, and signal processing. The Boolean type, often shortened to bool, represents true or false values. Booleans are fundamental in control flow and logical operations. In the code block, you can see some examples of complex numbers. C1 is assigned the complex number 3 plus 4j, and C2 is created using the complex function with a real part of 2 and an imaginary part of 5. You can access the real and imaginary parts of a complex number using .real and .imag. The code block also contains the Boolean examples. Is_active is assigned the value true, and is_complete is assigned the value false. You can also convert other data types to Booleans. Any non-zero number will be converted to true, while 0 will be converted to false. Let's dive into the text type, which in Python is represented by strings, abbreviated as str. Strings are ordered sequences of characters and are immutable, meaning they cannot be changed after they are created. Python strings support Unicode by default, allowing you to represent characters from various languages. String creation can be done using single quotes, double quotes, or triple quotes for multi-line strings. Strings have a rich set of methods for manipulation, such as converting to uppercase or lowercase, finding substrings, and formatting. For example, S1 is assigned the string single quotes, S2 is assigned the string double quotes, and S3 is assigned a multi-line string using triple quotes. The string name Python, we can use the upper method to convert it to uppercase, the lower method to convert it to lowercase, and the find method to find the index of a substring. String formatting is a powerful feature that allows you to embed variables directly into strings. In this case, the variable age, which is set to 30, is embedded into the message using an f string. Moving on to sequence types, let's begin with lists. Lists are ordered and mutable collections of items. This means that the order of elements is preserved, and you can modify the list after it is created. Lists are incredibly versatile because they can contain different data types. They are indexed from 0, meaning the first element is at index 0, and they can dynamically resize as you add or remove elements. In the visual representation, you can see a list containing various data types such as the string apple, the integer 42, the Boolean true, another list containing 1 and 2, and the floating point number 3.14. Each element has an index starting from 0. Here are the ways to work with lists. To create a list, you can use square brackets and include different data types. To access the first element, use the index 0, and to access the last element, use the index -1. To modify a list, you can assign a new value to an element using its index, append an element to the end of the list using .append, and remove an element by its value using .remove. Next, let's explore tuples, another type of sequence in Python. Tuples are ordered, immutable collections of items. This means that once a tuple is created, you cannot modify its elements. Tuples are more memory efficient than lists and can be used as keys in dictionaries because of their immutability. On the right, you'll see a quick comparison between lists and tuples. Lists are mutable and defined using square brackets, while tuples are immutable and defined using parentheses. Creating a tuple is similar to creating a list, but instead of square brackets, you use parentheses. If you're creating a tuple with a single element, you need to include a comma after the element to differentiate it from a regular expression. Accessing elements in a tuple is the same as with lists using indexing. Tuple unpacking allows you to assign the elements of a tuple to individual variables in a concise way. The asterisk syntax can be used to assign the remaining elements of a tuple to a list. Now let's explore dictionaries. Dictionaries, represented as Dict, are unordered collections of key-value pairs. Dictionaries are incredibly useful for storing and retrieving data in a structured way. The keys in a dictionary must be immutable, meaning they can be strings, numbers, or tuples. The values, on the other hand, can be of any data type. Dictionaries offer fast lookups by key, with an average time complexity of 01. Dictionaries are mutable, meaning you can modify them by adding, removing, or changing key-value pairs. In the visual representation, you can see a dictionary with keys name, year, and is _up, and their corresponding values Python 1991 and true. The keys are associated with their values through connecting lines. To create a dictionary, you use curly braces and define key-value pairs separated by colons. To access a value, you can use the key in square brackets or use the .get method, which allows you to specify a default value if the key is not found. To modify a dictionary, you can assign a new value to an existing key or add a new key-value pair. Let's explore set types. Sets are unordered collections of unique elements. This means that sets do not allow duplicate values. Sets are highly efficient for membership testing and support mathematical set operations such as union, intersection, and difference. Python offers two types of sets: set, which is mutable, and Frozenset, which is immutable. On the left, you'll see some common set operations: union, intersection, and difference. Union combines all unique elements from both sets. Intersection returns the common elements between two sets. Difference returns the elements that are in the first set but not in the second set. You can create a set by using curly braces or by using the set function. To create a frozen set, you use the Frozenset function. Sets support various operations such as union, which is represented by the pipe symbol, intersection, which is represented by the ampersand symbol, and difference, which is represented by the minus symbol. Now let's discuss the NoneType and type conversion. The NoneType represents the absence of a value or a null value. It is often used to signify the default return value of functions, or to indicate missing or undefined values. Type conversion is the process of converting between data types. Python provides built-in functions for converting values from one type to another. Some common conversion functions are int, float, str, and bool. In the conversion table, you can see the functions to convert to each data type. For example, you can use int with parentheses to convert to an integer, float with parentheses to convert to a floating point number, str with parentheses to convert to a string, and bool with parentheses to convert to a Boolean. Here are the examples. In the NoneType example, the result is assign the value none. In the string to number conversion, the string 42 is converted to an integer using the int function, and to a floating point number using the float function. To convert a number to a string, you can use the str function. In summary, Python offers a variety of built-in data types to suit different data needs. These include numeric types such as int, float, and complex, the text type str, sequence types such as list, tuple, and range, the mapping type dict, set types such as set and Frozenset, the Boolean type bool, and the NoneType. Understanding these data types and how to use them is crucial for writing effective Python code. For best practices, choose the right data type for your needs, use immutable types such as tuple and Frozenset for dictionary keys, leverage built-in methods specific to each data type, use type hints for better code readability, be explicit about type conversions, use sets for membership testing with large collections, and consider memory usage for large data structures. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.